In this problem, I'm asked to solve for d given the equation of 6d cubed minus 28d squared minus 10d is equal to 0. The first thing I would like to do is try to factor that left-hand side. I am going to look to see if there's a greatest common factor between my three terms. When I look at 6d cubed, negative 28d squared, and negative 10d, I can see that the greatest common factor of those terms is equal to 2 times d. Therefore, I'm going to factor out 2d from each one of those terms. When I factor out 2d from 6d cubed, I am left with 3d squared. If I factor out 2d from a negative 28d squared, I am left with negative 14d. And finally, if I factor out 2d from a negative 10d, I'm left with a negative 5. Let's verify that I factored this correctly. To return to my original equation, I could use a distributive property. Taking 2d times 3d squared is indeed 6d cubed. Taking 2d times a negative 14d is indeed a negative 28d squared. And finally, taking 2d times a negative 5 takes me back to a negative 10d. Now I am ready to continue to factor that left-hand side. The question that I would have to ask myself is, how am I going to factor 3d squared minus 14d minus 5? Well, one way I can do this is to use our factor by grouping. Therefore, I'm going to look for two terms that when I multiply it, I get the same as 3 times a negative 5, which is a negative 15. And I want these same two terms that when I add them together, I get that middle term, or negative 14. So two terms that add to a negative 5, two terms that multiply to a negative 15 that add to a negative 14 would be negative 15 times 1 because negative 15 plus 1 is equal to a negative 14. Therefore, using the factor by grouping method, I would take and rewrite negative 14d as negative 15d plus d. So we have 3d squared minus 15d plus d minus 5. In the factor by grouping method, I would group my first two terms together and my last two terms together. Looking at 3d squared minus 15d, I can see the greatest common factor is 3d. Factoring that out of the first two terms, I am left with d minus 5. I can see that my last two terms have a greatest common factor of 1. Therefore, in essence, I could factor out a 1 from d minus 5, and if I do that, I'm left with d minus 5. Now, as I look at this, I can see that both terms have a common factor of d minus 5, which means that 3d squared minus 14d minus 5 factors into d minus 5 times 3d plus 1. Going back to my original equation, I now have my left-hand side equivalent to 2 times d minus 5 times 3d plus 1, and that is equal to 0. I will notice that I have three terms being multiplied together to give me 0, which means one of those terms has to be equal to 0. So either 2d is equal to 0, or d minus 5 is equal to 0, or 3d plus 1 is equal to 0. Solving each one of those equations are going to tell me my solution for d. 2d equal to 0 tells me that d must equal to 0. If I have d minus 5 equal to 0, adding 5 to both sides would give me d is equal to 5. And finally, solving my last equation, 3d plus 1 is 0, I could subtract 1 from both sides, giving me 3d is equal to a negative 1. And then dividing both sides by 3 gives me d is equal to a negative 1/3. This would tell me that my solutions are 0, negative 1/3, and 5. Well, in order to verify my solution, I could substitute in d equal to 0, d equal to 5, and d equal to a negative 1/3 into my original equation to verify that my left-hand side would be indeed equal to 0. For example, when d is equal to 0, I would have 6d cubed, or 6 times 0 cubed, minus 28d squared, or 28 times 0 squared, minus 10d, or minus 10 times 0. I would see that my left-hand side is indeed equal to 0, verifying that 0 is one of my solutions. Again, I could do the same thing for d equal to 5 and d equal to a negative 1/3 to verify my solution.